We look up. We see planets: Mercury, Venus, Earth, Mars. These celestial bodies, each unique in their own right, have fascinated humanity for centuries. From the scorching surface of Mercury to the lush, life-sustaining environment of Earth, each planet tells a different story. Different worlds orbiting the sun, each one follows its own path, yet they are all part of the same solar family, bound by the gravitational pull of our star. But what if I told you, these planets aren't so different after all? What if their differences are merely superficial, masking a deeper, more profound connection? What if they are, in fact, snapshots in time of a single celestial body, evolving over eons? Imagine a planet that changes its form and characteristics as it ages, much like a living organism. This is the radical idea we'll explore, the one-planet theory. A theory that challenges our conventional understanding of planetary formation and evolution. Imagine a cosmic dance, a slow, majestic waltz across billions of years. Planets, like dancers, move gracefully through space, their paths intertwined in a complex choreography. Planets born from the same swirling cloud of gas and dust don't just exist statically. They transform, they evolve. From their fiery beginnings to their current states, they undergo dramatic changes. Each stage in this evolution captured in the diverse planets we observe today. These stages are like chapters in a grand cosmic story, each one revealing a different aspect of planetary life. Think of it like looking at a family photo album. Each photo captures a moment in time, a snapshot of a person's journey through life. Baby pictures, awkward teenage years, mature adulthood. Each stage is distinct, yet they all belong to the same individual. Each picture shows the same person at a different point in their life. Similarly, the planets we see today may just be different stages in the life of a single celestial entity. The one-planet theory suggests our solar system's planets are like these photos. They are different expressions of the same underlying reality, evolving over time. They provide glimpses into a grander interconnected narrative of planetary evolution. A story that spans billions of years, revealing the dynamic and ever-changing nature of our solar system. Venus, in this theory, is not what Earth will become, but rather Earth's twin from times long before Precambrian. This radical theory reimagines the temporal evolution of celestial bodies, drawing connections and building bridges between the histories of Venus and Earth, exploring their similarities and differences across various epochs. To understand this theory, we need to rewind the cosmic clock. Go back roughly 4.6 billion years. Our solar system, a swirling cloud of gas and dust called a nebula. Gravity, the great sculptor of the cosmos, pulls everything inwards. The center collapses, igniting into our sun. The remaining material swirling around the newborn star begins to clump together. Dust grains stick to each other, forming pebbles, then boulders, then planetesimals. These planetesimals, drawn together by gravity, collide and coalesce, eventually forming protoplanets. This process, known as accretion, isn't uniform. It depends on factors like distance from the sun, temperature, and the composition of the protoplanetary disk. This variation in conditions leads to a diversity of planetary outcomes. The one-planet theory argues that this diversity isn't random. It reflects a temporal sequence, a journey through planetary stages. Let's start with Mercury, the smallest planet in our solar system, a barren world scorched by the sun. The one-planet theory posits that Mercury represents an early stage of planetary evolution. Close to the sun, blasted by intense heat and solar wind, Mercury likely lost much of its early atmosphere and volatile elements. Its surface, heavily cratered, tells a tale of constant bombardment, a reminder of the chaotic early solar system. Mercury's large iron core, disproportionate to its size, suggests a once larger planet, stripped down by the sun's relentless energy. Studying Mercury is like peering through a window into the distant past. It offers clues about the raw materials and processes that shape the early stages of planetary formation. If the one-planet theory holds true, then understanding Mercury's evolution is key to unlocking the secrets of our own planet's past. Next, we journey outward to Venus, often called Earth's twin due to its similar size and mass. But don't let the resemblance fool you. Venus is a hellscape shrouded in a thick, toxic atmosphere with surface temperatures hot enough to melt lead. The one-planet theory suggests Venus represents an ancient stage of planetary evolution, perhaps similar to Earth long before the Precambrian era. Venus's thick atmosphere, composed primarily of carbon dioxide, traps heat, leading to extreme surface temperatures. Could this be a glimpse into Earth's distant past? Perhaps. Venus serves as a stark reminder of the ancient conditions that shaped our own planet. It highlights the importance of understanding ancient climates and the potential lessons they hold for our own planet's history. And then, we arrive at Earth, our home, a vibrant oasis teeming with life. From the vast expanse of space, our planet stands out as a beacon of blue and green, a testament to the delicate balance that sustains us. We exist in the Goldilocks zone, the perfect distance from the sun for liquid water, the lifeblood of our planet. This zone is neither too hot nor too cold, allowing water to remain in its liquid state, which is essential for life as we know it. But the one-planet theory challenges us to see Earth not as unique but as a stage, a fleeting moment in the grand tapestry of planetary evolution. It suggests that many planets may go through similar stages, each with its own story to tell. Perhaps billions of years ago, Earth resembled a young Venus shrouded in a thick atmosphere. Volcanic activity was rampant and the surface was a hostile environment, far from the hospitable world we know today. Over time, through geological processes and the emergence of life, our planet transformed. The atmosphere cleared, oceans formed, and the first signs of life began to appear, setting the stage for the incredible diversity we see now. Oceans formed, continents shifted, and life in all its diversity flourished. From the simplest microorganisms to the most complex ecosystems, life found a way to thrive in every corner of the planet. Earth, according to the one-planet theory, is a snapshot of a planet in its prime, a testament to the remarkable power of time and evolution. It shows us what is possible when the conditions are just right, and life is given the chance to flourish. But it also serves as a reminder that this moment is temporary. The forces that shaped our world are still at work, and the Earth will continue to change, just as it has for billions of years. The Earth we know today will continue to evolve, perhaps one day resembling the barren landscapes of Mercury or the scorching heat of Venus. This reminds us of the fragility of our existence and the importance of cherishing the time we have on this beautiful planet. Our journey continues to Mars, the red planet, a world that has fascinated humanity for centuries. Once a world with flowing water, now a cold, dry desert. The Martian landscape tells a story of dramatic transformation. The one-planet theory proposes that Mars represents a stage of planetary evolution that Earth might one day reach. This theory suggests that Mars, in its ancient past, might have been more Earth-like, with rivers, lakes, and perhaps even oceans. Evidence suggests Mars once had a thicker atmosphere and liquid water on its surface, potentially even hosting life. Ancient riverbeds and mineral deposits indicate that water flowed freely across the Martian surface. However, Mars, smaller and further from the Sun than Earth, faced challenges that our planet did not. Its size and distance from the Sun played crucial roles in its climatic and atmospheric changes. Mars lost its magnetic field, leaving it vulnerable to the solar wind. Without this protective shield, the solar wind stripped away much of its atmosphere. This stripped away much of its atmosphere, causing its water to evaporate or freeze beneath the surface. The once vibrant planet became a barren desert. The loss of atmosphere and water transformed Mars into the cold, arid world we see today. Yet traces of its watery past remain, hidden beneath the surface in the form of ice. Mars, a faded portrait of what Earth might become, serves as a stark reminder of the fragility of planetary environments. It shows us that even a planet with potential for life can undergo drastic changes. This reminds us that planetary evolution isn't always a linear progression. Planets can undergo periods of growth and decline influenced by a myriad of factors. Planets can regress, their environments changing over time due to both internal and external forces. These forces can include volcanic activity, asteroid impacts, and solar radiation. The study of Mars serves as a crucial piece of the puzzle, helping us understand the long-term habitability of planets and the potential challenges to sustaining life. By studying Mars, we gain insights into the processes that can alter a planet's environment. This knowledge is invaluable as we look to the future, not only for potential human exploration and colonization of Mars, but also for the preservation of our own planet. Understanding Mars's past helps us prepare for the challenges that may lie ahead for Earth.